Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. First of all, thank you for watching this video. We are from team PBL-TRPL406 and we will be presenting the progress of our project entitled Sigma, Smart Integrated Guardian for Monitoring and Assistance. And let me introduce my team. First, Jatuh, our team leader and AI machine learning engineer. Muhammad Hasan Firdaus as a system architect and IoT hardware engineer. Hasna Fadila Ramadan as a software developer and code engineer. Nanda Prasetyani as a IoT hardware engineer. Rifana Alwarin as a business analyst. Muhammad Maulana Yusuf as a UI UX and product design engineer. So, this is the objective and the problem. Blind and elderly people often face risks, like falling or bumping into objects. Their family usually don't know their location or if they are in trouble. So, to solve this problem, Sigma is designed to help users stay safe and independent, with real-time location monitoring and emergency alert.
So, to achieve this goal, Sigma is designed with three main features. The first is fall detection, so these features can detect when the user falls and automatically sends an emergency alert to their family, so help can come faster when it's really needed. The second is obstacle avoidance. The smart can use sensor to detect nearby objects and give vibrations or sounds warning to helping users move safely. And the third is emergency tracking. So these features allow the user's locations to be tracked in real time by mobile applications, so family members always know where they are, especially in emergency situations. So hopefully, with this feature, Sigma is not only helps users move more safely and independently, but also give peace of mind to their family because they can monitor and respond quickly when something gets wrong.
Okay, next we have a three flow chart. First is fall detection flow chart. The process began with a motion sensor that continuously read data. If there's no fall detect, the process will repeat to keep reading data. But if fall is detected, the system will check to see if there has been no movement for 1 minute. So when movement detect, the system return to monitoring, but it's still no movement detect, the system send the first notification. And then the system monitoring the user condition. If the user move detect, the system or the incident is considered resolved. But if no response, the system will send a second notification. And if the user still no movement detect and there is no response from their family, the system will send a notification to nearby user. And if there's still no response again, the system will call an emergency contact. And the second is map tracking flowchart. So the process began with the module initialization, followed by reading GPS coordinate. The system then check whether the coordinates are successfully obtained. If the coordinates are available, the system use them, but if not, the system will use the last known location, and it's all the data will send via MQTT. After that, the system wait for a certain interval before repeating the process. And last is obstacle detection flowchart. So the process begins with the sensor continuously reading data. If data is used to detect whether there is an object nearby, if no object is detected, the system repeats the process by reading sensor again. If an object is detected, the system compare a distance to a predefined safe threshold. If this distance is still with the safe limit, the system returns to monitoring. And if the object is closer than safe threshold, the system provides a warning to user through vibration or buzzer.
Alright, now I'm going to explain the design and equipment scheme of our Guardian Stick or Sigma. So here, the system starts with two 18650 lithium-ion batteries connected in series, managed by a BMS for safety, and charged via a V1049 USB Type-C step-up module. A LM2596 step-down converter here regulates the voltage down to 5 volt to power all of our components. At the heart of our system is the PCB or the printed circuit board, which integrates the ESP32 microcontroller, the SIM800L GSM module for internet connectivity, MPU 6050 accelerometer and gyroscope for fall detection, and the GSN SRO40 ultrasonic sensor for obstacle detection. The GPS Neo 7M provides real-time location tracking, while the user feedback here is delivered through a vibration motor and active buzzer. Right. So on the right here, we can see the actual physical prototype. The PCB is housed inside a compact casing attached to the cane handle with the ultrasonic sensor mounted at the lower section for obstacle coverage. So together, all of these components enable Guardian Stick to detect faults, avoid obstacles, track location, and send emergency alerts.
Now we are talking about device specification and operation. At the center is the ESP32, which connects all sensors and handles data processing. For fault detection, we use an MPU 6050 sensor with tiny ML to detect abnormal movements. If a fault occurs and no movement is detected afterward, the system triggers an alert to the mobile application. Users can also manually send emergency signal using the panic button. For location tracking, a GPS module provides real-time coordinates, while an ultrasonic sensor detects nearby obstacles and activates a buzzer as a warning. All data, including fault events, SOS signals, and location, is sent via SIM-X00L GSM module to the internet using MQTT protocol. On the server side, the backend process and store data in database, and send notification to mobile app using Firebase Cloud Messaging. This allows caregivers to monitor user condition and location in real time, ensuring fast response during emergency. Okay, next we are going talking about implementation progress. In the first week of implementation, we set up code base and focus on hardware development. The obstacle detection functionality is fully implemented, while the panic button and GPS location feature are partially integrated with MQTT broker.
Okay, next I will explain about the course contribution for our project. First, we have calculus. Calculus allows process numerical data like latitude, longitude, and accuracy values. Second, we have artificial intelligence. This course allows determine the technique to be used at computing, which is random forest tiny ML to detect fall even from MPU 6050 sensor input. For software maintenance and security, we ensure user comfort and maintain data security regularly while managing our backend and database. Then hardware programming, we use it to connect all existing physical IoT components into the system. Lastly, general English allows read and write technical document like final report, and the IoT project course guides our teamwork in building this prototype. Moving to slide 11. This slide shows the documentation of our discussion with the project manager, Manpro, regarding the IoT project as well as discussion with our other course lectures. That is all from me. Thank you, and I will give it back to the moderator.
That's all for our presentation. We are hope our project will be useful for the future. Thank you for listening. Wassalamualaikum warahmatullahi wabarakatuh.